want to acquire a TV set, then the one option is, although not an ethical option, that is the stealing of the TV set. Other option is you can earn money and buy the TV set. So earning money and buying are basically two not independent, they are dependent activities. So earning money, then buying. So these two will lead to acquiring the TV set, right? So basically that is why we are connecting them through an and arc. And arc means that they are basically dependent activities. And if it is an independent activity like stealing, so it will be an or arc. Or arc means there is no arc, it's called as an or arc. It's an independent subtask. So if you I mean, if it is a action of stealing, then you can directly then it will directly lead to acquiring the TV set. So it's an independent subtask. So now let us see that how we basically give the costs in a and or graph. This is called an and or graph. So basically each operation has a uniform cost, and each arc with a single successor has a cost of 1, and arc with multiple successors has a cost of 1 for each of its components. Okay, so I'll tell you how to do the cost calculations using this graph. So just see this graph here, students. You have a node A and you are generating B, C, and D from that. And then from B, you have the children as EF. From C, you have GH. And from D, you have IJ, right? So basically, the costs of the leaf nodes are given to you. Okay. So for EF, it is given as 5 and 10. For GH, it is 3 and 4. And for IJ, it is 15 and 10. So how do you calculate the cost of an AND arc? So the arc on B, which is leading to the children E and F, that you will calculate. Okay, and then you will calculate the arc of C and for D, and then finally you will calculate the arc of A, basically. So what happens in the case of problem reduction is the algorithm starts by taking the initial node as A, and we look for the best possible path from A, right? So there are two paths from A. If you see this graph, the first path is the left path through B, and the other path is through CD. Why I am saying CD combined? Because that is only one path, because it is connected by an and arc. So there is only two paths. There are only two paths from A, one through B, other through CD. Fine. So now you have to find out which path is better. Okay, so the path through B, you have to find out whether it is better or the path through CD is better. So basically, if you, let us say we want to find out the path through B, the cost of the path through B. So first of all, we have to expand this B into EF. Okay, so what we do is just see this solution. We consider the path through B. So basically your B is generating the children E and F. So first of all, we have to find out, I mean, what is the cost for this particular arc. Then only we can propagate this cost upwards to find the path up from A. So first of all, you have to find the cost of the path through B. So E and F are your terminal nodes. So therefore, the cost of EF path would be the cost of heuristic value of E plus the heuristic value of F plus, so see here, each arc, each and arc with multiple successors has a cost of 1 for each of its components. Okay, so basically whatever is the cost of E and F, you have to add 1 as an edge cost. So for E, 5 plus 1, for F, 10 plus 1. So basically you have to add the heuristic values plus the edge cost in order to get the cost of that arc. So the arc of B will have a cost of the cost of E plus cost of F plus the edge cost for E and the edge cost for reaching F. So the edge cost for reaching E through B is 1 and the edge cost of reaching F through B is also 1. So 5 plus 1 and then plus 10 plus 1. So that is how you calculate the cost of an AND arc. So AND arc, whatever successors the AND arc has, we have to add the costs of those successors plus 1 for the edge cost for each of the successors. Okay, so this is how you calculate this is how you calculate the cost of the AND arc. So basically the cost of EF path through B is the heuristic value of E plus the edge cost of BE plus the heuristic value of F plus the edge cost of BF. So that is 5 plus 1 plus 10 plus 1. So that gives me 70. Okay. So So basically, this is through this assumption. So the assumption is, yeah, if B gives EFZ, so what is the question? If B gives EFZ all connected by an AND arc, then we add 4 or 3 for the AND arc? 3 you will add for the AND arc. Okay. If three successors are there, then 3 you will add. One for each successor. So the number of successors, basically it depends upon the number of successors. So for each successor you have to add a 1 for the edge cost for that successor. So basically each AND arc with multiple successors has a cost of 1 for each of the successors. Okay. So if there are 3 successors, you will add their cost plus 1 for each of the successors. So that means plus 3. Fine. Okay. So now, fine. So now you basically see that that the cost is 17 to that B. So for this B arc, the cost is 17, right? 5 plus 10 plus 2. Now you propagate this cost of B upwards to A. Basically, you want to find out the cost from A, right? Till now you have found out the cost from B. So you have basically found out, you have made your current node from A to B, and now you are finding out what is the cost of the path from B to EF. So basically, now you will propagate this information above to find out the cost of the path from A. Okay. So the cost of the path corresponding to B is the cost of EF path, plus you will basically add the edge cost AB in order to find out the cost from A. So basically the cost of B is 17. So 17 plus 1 would be the cost from A, because this is an OR arc, because A and from A you are generating B, and there is no AND arc for B from A, right? So that is an OR arc. So basically whatever is the value of B, that value of B plus the edge cost of AB. So every time you have to add the edge cost that is there. So that is basically you have to add an edge cost everywhere. So 17 plus 1 will give me 18. So 18 is the cost of going from A towards the path through B towards EF. So the left hand side branch of the tree has a total cost of 18 starting from A. Is it okay? At the right hand side branch of the tree is an AND arc. Now let us try to calculate the cost of this AND arc. And then we will decide that which path we should follow. Fine. So first of all, we'd start from the leaf nodes and calculate the cost of the arcs and propagate the information upwards until we reach the root node. Now from the root node, we have multiple costs of multiple successors, and we find out which path is the best one to follow. Then we follow that path. So basically, you have found out the left hand side branch of the tree's cost as 18. Now you find out the cost through CD arc from A. So the cost of CD arc would be the cost of C plus the cost of D plus 1 for C, that means the edge cost AC, plus 1 for D, that means the edge cost AD. So basically whatever is the cost of C plus the cost of D plus 2, right? Now what is the cost of C? Again you have to expand the C to GH, and whatever is the cost of G plus the cost of H plus 2, that will give me the cost of C, and similarly for D, right? So what is the cost of C? Basically the cost of G plus cost of H plus 2. So cost of G and H is given to you as 3 and 4. So what is the cost of the AND arc C, AND arc on C? It is basically 3 plus 4 plus 1 plus 1. So that gives me 9, right? So the cost of the AND arc on C is 9, because it is basically the cost of G plus the edge cost CG plus the cost of H plus the edge cost CH. So that gives me 9. So now basically so you have got the cost of C as 9. Now you have to also calculate the cost of D, because C and D are connected by an AND arc. So in order to solve A, you have to solve both C and D, right? So you calculate the cost of D also now. So D has generated two children, I and J. So I has got the cost of 15 and J has got the cost of 10. Fine. So the total cost is 25 and plus 1 is the edge cost for D to I, and 1 is the edge cost from D to J. So plus 2. So that gives me 25 plus 2 is 27. So 27 is the edge cost of D arc. Now you propagate these costs upwards to calculate the cost of A arc, right, through this path. So you know the cost of C is 9 and the cost of D is 27. So the cost of A would be the cost of C plus the edge cost of AC plus the cost of D plus the edge cost AD, right? So that will be basically 9 plus 1 plus 27 plus 1. See the chat box, students? So basically that will be 9 plus 1 plus 27 plus 1. That gives me 38. That gives me 38. That's how you get the cost of A through this right hand side branch of the tree. Fine. So basically, every time you calculate, you want to find out the best path, you have to traverse the tree down up till you reach the leaf nodes, and then you propagate the information upwards so that you get the cost from the root node for each of the paths. Then you select the best path. Okay, so here you have propagated from A to B, then EF, and then you found out the cost of EF and you propagated the information upwards to the root node. Then you found out the cost of A was 18 through the path then B, then EF. So that cost was 18. Then similar thing you did for the right hand side branch of the tree. So you found out the cost of this AND arc as the cost of C plus 1 plus the cost of D plus 1. And similarly, you have to solve for C and D also and find out the cost. Then finally, when you will get the cost of A through this right hand side branch of the tree, at that time you will basically have two costs for two different paths. Then you will select the best path. So what is the question? How is AND arc making a difference in the H value? It is making a difference in the H value in the sense that in order to solve A, you have to solve both C and D. Okay. Otherwise, there would be three branches of this tree. From A to B, then from A to C, then from A to D. But since this is an AND arc, so there are only two solutions possible. One solution is through B, other solution is combined through C and D. Okay, so basically whatever is the heuristic value of C and whatever is the heuristic value of D, you have to add both of them and plus 2 in order to get the total cost of A through this path. That is the use of an AND arc. So basically AND arc is making your number of solutions restricted, and from those basically it is making a difference in the paths which are possible. Right. So basically to solve A, you have only two paths possible, one through B, other through CD. Fine. So if you see the solution, so first of all, we had calculated the path through B and we got a cost of 18. In this, we are calculating the path through CD and basically we get this 38 as the cost. So the best cost path is, which one will be the best cost path? Through B, obviously, because the path through B is having a lesser cost. So the correct path from A would be A, then B, then EF. Why I am writing EF together? Because E and F both have to be solved in order to proceed further, right? Because they are connected by an AND arc. So the solution path is, best cost path is ABEF. So this is how we do the problem reduction, and this is basically when you connect them by an arc, that is an AND arc. So they are dependent activities, and if you don't connect, then it is an independent activity. But in both the cases, you have to add the edge cost in order to propagate the cost upwards. So you have to add the edge cost for an OR arc also and for an AND arc also. So was one example to tell you that how problem reduction, how the AO star algorithm actually works, right? Now we will see this algorithm. It's just the thing which I have just explained to you. It's the same thing basically. So if you see here, you have a graph and a starting node, and you have some leaf nodes, and you have a heuristic function available to you. So these four things you have, and you start with the initial node from the graph G and call it the init node. Now what you will do is basically just see this graph. Basically, if you see this graph, you are starting from an initial node, and until that node is reaching to some leaf nodes, or you can say the goal states. Till that time, you expand the nodes and generate the successors and add the successors to the graph and just go on. Basically, you generate the successors, then you generate the successors of the successors, and you go on until you reach the leaf nodes or the goal state. So, if you have reached the leaf nodes through multiple paths, or you can say you have reached the goal state through multiple paths, so then you have to find out which path is better. So basically, that is what is happening in the second step. Until your initial state is labeled solved, or you have exceeded some futility limit, right? Futility limit means that I don't want to generate, I mean, the cost has exceeded. There was a threshold beyond which the solution generated could not be accepted because of too high cost. So that is called as a futility limit. So until your initial node has reached the futility limit, or it is labeled solved. Solved means it has reached the goal state. So till that time you will repeat the procedure. The procedure is you will just find out what are the unexpanded nodes, basically what are the unexpanded nodes which are there, and then you will generate the successors of those nodes, and basically you will add the successors also to the graph, and then if the successor is not a leaf node, then you will compute its heuristic value and again generate its successors and so on. So basically in the second step you are basically generating this kind of a tree. Okay, so this kind of a tree you are generating up till the leaf nodes in the second step. So this is what is the AO star algorithm second step. Now the final step is propagate the cost upward. So if you see here, this is the final step, propagate the newly discovered information up the graph. So this is the step where you are basically propagating the cost upwards in order to find out the best path through the root node. So there could be multiple paths possible from the root node. So in this third step, you are propagating the cost from the goals, I mean the leaf nodes upwards in order to decide the best path. So how do you propagate the cost upwards? Basically through the same procedure which I have just explained. If you have an AND arc, then you will basically compute the cost of that AND arc. So it will be basically equal to the heuristic value of the nodes at the end of the arc plus the cost of the arc itself. So basically cost of the arc means that the edge cost basically. So heuristic value of the first successor plus 1 for the edge cost plus the heuristic value of the second successor plus 1 for the second edge cost if there are two successors. If there are three successors, then heuristic value of the first plus heuristic value of second successor plus heuristic value of third successor plus edge cost of first, that means 1 for the first, then 1 for the second, then 1 for the third. That means a total of plus 3. Like this, you will calculate the cost of AND arc. Fine. So now when you calculate the cost of this AND arc, so let us say you have calculated the cost of one AND arc, and then you will basically, so just see this example. If you have calculated the cost of this C arc and the D arc, fine. Now, basically, if basically you want to propagate this cost information to A, so in this case it's an AND arc, so you are adding the cost of C plus D plus 2 in order to calculate the cost of A arc, right? But suppose if this was not an AND arc, if this was an OR arc, that means there was no arc in between, correct? So if there was a OR arc from A to C and D, fine, so that means there were three paths possible from A, one through B, one through C, other through D, correct? Fine. So in that case, you will basically find out the best path out of three paths because they are not dependent now. C and D are not dependent activities now because there is no AND arc on A. Fine. So in that case, you will find out the best path out of three paths. The B path, the C path, and the D path. So in that case, whatever path is returning the least cost, that will be your that would be leading to the basically that will be propagating its information to A. So suppose there was no AND arc from A towards C and D. So in that case, the cost of B was 17, the cost of C is 9, and the cost of D is 27. So which one, what will be the cost of A in that case? Can anybody tell me what will be the cost of A in that case? The question is there is no AND arc between A. There is no AND arc on A between C and D. Yes, so that is a good answer. It's correct. It's exactly, yeah, exactly what I was expecting. So basically, it's not nine, it's nine plus one. Yeah, I thought that somebody might miss that thing, but that's good. So basically, there are three options. Through B, it is 17, through C, it is 9, and through D, it is 27. So the final cost would be the least cost path, that is through C, and the cost of A through C would be 9 plus 1. Why 1? Because the edge cost you have to add, irrespective of whether it is an OR arc or an AND arc. So 9 plus 1 means it will be 9 plus 1. That means 10. So 10 would be the cost and the path would be ACGH. Right? So the path would be ACGH in that case. But since this is an AND arc, so in this case we have added the costs of C and D and then we have added the edge cost and that has become the cost of A through this path. So that is why we got a 38. So in that case the cost was 10 and now it is actually we have taken the best cost path as 18, right? So this is the difference. 10 you have got the case in which you have only OR arcs. Okay, 10 is the cost, 10 is the best cost in the case of only OR arcs. And in this case where you have AND arcs also, the cost is 18. Why 18 I am saying? Because the cost is through B. The best cost path is through B. So that is 18. So in the case of only OR arcs, you got a cost of 10. In the case of AND arcs also, you got a cost of 80. So now you can understand the difference between if you use an AND OR graph or simply if you use an OR graph. Nitin, can you get the difference now? You were asking what is the difference in the heuristic values if you use both the arcs? Right, fine. So this is how you proceed with problem reduction. So this is basically the AO star algorithm. It's written over here also in the AO star algorithm. First of all, you start with the initial node. Then you try to label this node as solved or until you reach the futility limit, you will generate the successors. You will go on generating the successors until you reach the terminal nodes. Terminal nodes are those nodes which have got the goal state. Now you can get the goal state through multiple nodes or multiple paths. So you will propagate the cost upwards and then find out the best path. So this is these all the steps from A to F are the steps where you are basically propagating the cost upwards. Okay, so you are selecting a node and then calculating the cost of each arc emerging from that node, then assigning the minimum of the cost value. Minimum of the cost means if there are two arcs, then you will assign the minimum of them. Basically, that is what we have done in that example. Then you find the best path, and then you again propagate from the best path upwards until you reach the root node, basically. So this is the same thing which I have just explained, how to propagate the cost upwards. This is the same thing. This is nothing but the AO star algorithm. Okay. So basically, this is just they have used some variables also here, and but the thing is the same thing which I have just explained now only, and basically this current is basically the node which is when you are propagating the cost upwards, you are basically making the current change in order to basically indicate the current node which you are trying to find the cost. So current node is basically the node for which you are trying to find the cost currently while propagating the cost upwards. And if the current has been labeled solved or basically then basically you have reached that particular root node and it has a root node should be solved. So basically root node has to be solved in order to solve this particular problem. So if you propagate the cost upwards and finally and you are labeling the node as solved, it means that it has got a path towards the goal state. Are you able to get this, students? Please read this. Any doubt in the algorithm? Please read the algorithm. Please ask students, is it clear? AO star algorithm. I will take another example also to tell you. But is the algorithm process clear to you? What are we doing in the algorithm? Say yes or no. Clear? Okay, fine. Okay, fine. So this is basically whatever I have explained. The same thing is written in this algorithm only. Just 2 points you have to remember in this algorithm. The first important point is you have to basically generate the successors of the from the starting from the root node. You have to generate all the successors. So basically you have to what I mean is you have to generate this kind of a tree which leads towards the leaf nodes. So you have to generate, and leaf nodes we are assuming they are the goal states basically. So you can have basically multiple paths leading to the leaf nodes. Fine. So this kind of a tree you will generate in this step, in this second step. Fine. Go on generating the successors. If and if there are if the successors are generated, then you add the successors also to the graph. If the successor is a terminal node, then label it solved. Fine. And calculate its heuristic value. That will be 0. If it is not a terminal node, then you just compute its heuristic value. So you'll go on basically generating this kind of a tree until you reach the goal nodes. And at the goal node, the heuristic value would be 0, right? So this is just an intermediate part of the tree. It is not the complete tree. Fine, like this you will do. And in the third step, you are basically calculating the cost upwards towards the root node. So you are selecting, so there will be a set of nodes which have been marked as solved. Solved means they are basically able to reach the goal state. So those, there will be different paths for reaching the goal state. Now you basically take that S as a number of nodes and select from S a particular node, call it the current node and remove it from S and compute the cost of the R's emerging from that current node and find out the best cost path. Then you just propagate the changes upwards until the root node has been labeled as solved. So the same thing which I just explained. Fine. Now, this is the working of AO star algorithm. And one important thing in AO star algorithm is that AO star algorithm does not use the specific or explicitly a G value. Why I'm saying the AO star algorithm does not require explicitly a G value? In the A star algorithm, we had a G value, right? In AO star, we don't have a G value explicitly. Why? Can anybody answer? It's already considered. Okay. How? As edge cost. Correct. Yes. So basically, that is the correct answer which Nitin has given. Basically, we are considering the edge cost, right? Whenever we are calculating the cost upwards, whenever we are propagating the cost upwards, we are actually adding the heuristic value plus 1 as the edge cost, right? So then only we are propagating the cost upwards to the parent node, right? So for example, if you take from B, you generate E and F, so you are taking the heuristic value of E as 5, and then when you propagate this heuristic value upwards towards B, you take it as 5 plus 1, right? And similarly for F, you take it as 10 plus 1. So already you are considering that as a edge cost. So that is why G value is not explicitly required in the AO star algorithm. So that's what is explained here. So G values are basically not required to be stored because it's not necessary also, because we are propagating the, while we are propagating the cost upwards, we are already calculating the edge cost. So when you calculate the best path from the root node, you have already considered the edge cost, which is nothing but the path values. So we are already considering the best paths. So we don't need a G value, because through the edge cost, we have already considered the best path only. Fine. So in the AO star algorithm, whenever we are trying to find out the best node to move on. So for example, if from this A, we want the best node to move on, that is B. And in that B, we have also considered the path length, right? Because we have considered the edge cost. So that is why edge costs are already considered. So we are always on the best path. We are always on the best path. So we have also considered the heuristic cost plus the best cost path. That's why we don't need a G value explicitly. And we use depth first search to traverse the graph. We use depth first search to traverse the graph because we are moving along one branch of the tree. And then when we are, for example, when I am selecting here the path through B, then from B I am going to E and F. Then from E and F I might be going to the children of E or F, like this. So it's a depth first search basically. AO star algorithm would be a depth first search basically because it proceeds along one branch of the tree, which is the best cost path. Now let us do one other example to tell you more about AO star algorithm's problem reduction process. So this is another example. A is given to you, okay, and we have to generate the tree through A using problem reduction technique. So A generates B, C, and D, let us say, and let us say B and C are connected by an AND arc, and the cost of B is 4, C is 5, and D is 6. Can you now find out which path would be better and what will be the cost of that path? See, the cost of path through A from A towards there are two options. One is through D, other cost path is through BC, right? There are only two options. There are no three options. There are only two options, right? So one is through D, other is through BC. So what is the cost through D? If you see the cost of D is 6. So the cost, when you propagate this cost upwards to A, the cost of going through D would be 6 plus 1, 7 through the path AD. See the chat box, students. It will be 6 plus 1, 7 through AD, right? Now you calculate the path through BC. So the cost path through BC would be the cost of B plus 1 plus the cost of C plus 1. So that will be 4 plus 1 plus 5 plus 1. So that will be 5 plus 6. That is nothing but 11. Right? So that is the path through A to BC. Fine. So the path through A to BC would have a cost of 11 and the path through A to D would be having a cost of 7. So now which path you would choose? The lesser cost path. That means you will choose the path through D. Fine. So now when you choose the path through D, you will expand D. Now let us say when you expand D, you generate I and J and they have the heuristic values as I has got 5 and J has got 10. Fine. These are the heuristic values. And let us say they are also connected by an AND arc. So there is an AND arc on D also for I and J. Fine. Now can you calculate the cost and tell me which is the better path better path now? A to BC, BC path. And what is the cost? 11. Okay. So how you've calculated that 11? Okay, 11 was already there. But how do you calculate for IJ path? So basically I is 5, J is 10. So the cost of I for when you propagate it upwards it is 6 and for J it is 11. So 6 plus 11 is 17. So what is the cost now for this path ADIJ? What is the cost? 17 plus 1. Correct. So that is 18. So you have two options. One is the left hand side branch. So that is A to BC path and that is having a cost of 11. Fine. The other is A to D to IJ path and that is having a cost of 18. Fine. So basically you are having a cost of 18 as the right hand side branch of the tree is cost and the left hand side branch of the tree has got the cost of 11. So basically you choose the left hand side branch of the tree. Now you choose the left hand side branch of the tree in step number 3. Now which node you will expand? See, you will go to the left hand side branch of the tree, but that is an AND arc. So you have two options. Basically it's an AND arc. It's an AND arc. So you have to basically solve both B and C in order to solve A, right? Because it's a dependent activities. So now which one you will solve first? So we generally solve the lower cost node. So B and C are having the cost of 4 and 5. So you basically expand B first. So you expand B to E and F. Fine. So you expand B to E and E and F are, let us say, they are having a cost of 6 and 7. So there is no and arc between E and F on B. Okay. So this is one new thing basically. This is also one important thing over here. So when you are proceeding on an and arc, then which one you should select for expansion? You should select the lower cost one. That is why you selected B for expansion. Then the other thing is, if you have an or arc, basically they are independent activities, then which you should select for, basically then how you should calculate the path cost upwards. So E and F are independent activities. They are connected through an OR arc, right? So basically, they are connected through an OR arc. Just a minute, students. Yeah. So, can you hear me, students? Okay, fine. So basically, you were basically then. So the thing was, which I was explaining was that if you are having the generation of E and F from B, then in that case, how you will propagate the cost to B. So this is an OR arc. Okay. So you have to remember this thing, that in the case of an AND arc, you add the cost of E and F and you add a 2. So E cost is 6, F cost is 7. So 6 plus 7 plus 2 would be the cost of B in the case of an AND arc. But in the case of an OR arc, you have to take the lower cost node and you have to add a 1 for that node, okay, to propagate the cost upwards. So basically, from B, you have generated E and F, and these are independent activities. So that means either you can solve E or F in order to solve B. Fine, because it's an OR arc, right? So which one you would solve? You would obviously solve the lower cost one, because if you solve E also or you solve F also, both of them can lead to the solution of B, right? So that is why E you would solve because it's a lower cost node. So you solve E first, so it will be 6 plus 1, 7, right? That is how you get the cost of B. So now you get the cost of B as 7, and you again propagate the cost upwards through, then B and C are joined by an AND arc. So when you propagate the cost upwards, you have to add the cost of B and C. So you add the cost of B as 7 plus 1, 8, and for C it is 5 plus 1, 6. So 8 plus 6 is 14, right? So basically, this is how you get the cost of A through left hand side branch of the tree as 14, and the right hand side branch of the tree is 18, right? So the left hand side branch of the tree has got 14 now, and the right hand side branch of the tree has got 18 cost. So basically, you will select the left hand side branch of the tree for expansion. So basically, you will select one of E and F for expansion. So you will obviously select E because it is a lower cost path. So you will select E for expansion, and then you will proceed further and so on until you reach the goal state. Fine. So you have to, after this step 4 also, you have to proceed further until you reach the goal state. Okay. So this is what is written on the left hand side in the explanation also. I have just explained you whatever is written over here. So So basically, in the last step, if you see, when you expand B to generate the children E and F, the cost of this node B becomes 7. And because I explained you the reason, because it's through an OR arc. E and F are through an OR arc, right? And the path via B and C is becoming 14, whereas the path via D on the right hand side branch of the tree is 18. So this path via BC is cheaper, so we choose this path. We continue until we reach the goal state. So that is how we are continuing in the case of an OR arc or an AND arc. So now, which node you will choose for expansion out of E and F? You will choose E because it's a lower cost node. So always, even if it's an AND arc or a OR arc, if you have two options to expand, you choose the lower cost node to expand. And how do you propagate the cost upwards? In the case of AND arc, you already know. For an OR arc, you have to choose the lower cost node and you have to add the edge cost of 1 to propagate its cost upwards. Is it clear, students? How do we do? So this entire process is called as a process of problem reduction, or you can say the AO star algorithm. Is it clear to you, students? Okay, only Nitin is responding. What about others? Are you able to understand or not? Okay, okay, fine. Okay, good then. Fine. So then this was about the AO star algorithm. Then there are two important things. See, these are some constraints about AO star algorithm. So in the AO star algorithm, a longer path may be better in some cases in the AO star algorithm. So a longer path may be better in some cases if the shorter path is basically an AND arc with one of the nodes as unsolvable node. So in this case, it would be better to reach a path which is longer but that is solvable. Let us see through an example. What I'm saying is, just see this path. Here you are going, suppose your goal state is E. Okay, E is your goal state. So your goal state is E and you want to reach E. Now there are two paths to reach E. One path is through A, then C, then E, right? A, C, E. Other path is A, B, H, J, and E. Okay, the other is a longer path through A, then B, then H, then J, then E. So that's a longer path. But actually, you would prefer this longer path because if you go to A through C, then that is basically C is also, in order to solve C, you have, I mean, if you want to go to E through ACE path, in that case, you have to solve, in order to solve A, you have to solve C and D both. And if you solve C and D, then only you can proceed towards E, right? Basically, C and D are joined through an AND arc, and D is an unsolvable node. Let us say D is a node which is not solvable. It is some state which cannot be solved or which can never lead to a goal state, basically. So, in order to solve this A, you have to solve both C and D. But actually, D is an unsolvable node. So, if you cannot reach this goal state E through this path because you will never be able to solve D, and if you are not able to solve D, then basically it is you cannot reach the goal state E. So in this case, a longer path would be better because that is containing all solvable nodes. But in the case of a shorter path, it is having an unsolvable node. So in some cases, longer path is better. So it's better in this case that we reach the node via a solvable path rather than via an AND arc which contains an unsolvable node, since this path can never reach a solution. Fine, this is one thing. Are you able to understand? Are you able to get this, students? Okay, fine. Other option. Okay, fine. I will explain again. 66 slide. Okay. Some doubt in slide number 66? Yeah. Please tell me, Abhishek. Yeah, what is the doubt, Abhishek?
Ma'am, okay. Uh,
Yeah, Abhishek.
Ma'am, if you want to solve A through, you have to expand both B and C. Yeah?
What? If you want to, what did you say? Repeat.
Ma'am, if you're choosing the path BC,
Yeah.
so we have to expand B and C regardless if I get the answer through B or C. Yeah?
You have to expand B and C both. Basically, in order to solve A, you have to solve B also, C also. Right. Correct.
So how does it matter if I expand B first or C first?
So basically, you might generate, see, in order to finally propagate the cost upwards, you will have to find the cost of B and C both, right? You have to find the cost of B and C and add them in order to generate the, find out the cost of this arc. To find out the cost of this arc, you have to get the cost of B also, C also. But if you are, so when you are expanding the lower cost path, you might be able to reach the goal state in, you might be able to reach the goal state in that path also. So it is basically, it is a, you can say normally, you can say it's normally a trend when you are expanding two nodes. Out of these, you always start with the lower cost node only, because that might be leading towards a solution. In this path only, you might have a solution. So generally, if you consider the heuristic values, so whenever we used to work with A star and best first search also, whenever you want to expand, you expand the node with a lower heuristic cost, right? That's what we are doing here also, a similar thing only. So
So it
this
would
is a,
not would it really matter if I expanded C first and I didn't get the answer because I have to anyway add that value to A?
right. If you don't get the answer, anyways, you have to expand B also, finally.
Okay, thank you.
Yeah. So if you get the answer, it is well and good. If you don't get, finally you have to expand C also, because anyways, for propagating the cost upwards, you need both B and C because they are dependent activities, right? So but when you expand it, then in that case, generally we expand the lower cost heuristic function node only. So that is a normal trend, right? So that is the case. Just because of that reason, lower cost nodes we expand first, then we expand the higher cost nodes. But if you are not able to get the solution, eventually you have to expand C also.
So it's just a trend. I don't have to follow it. If I could expand C first if I wanted.
No. See, when you have two options in the case of an AND arc, you will expand the lower cost path only, even if in the case of an OR arc also. See, in the case of an OR arc, you have choices, right? You can solve B via E or F. That is an OR. So in that case, you will choose the lower one only, because that lower one will lead to a goal state. Correct? Are
Correct. In
you?
case of all, that makes sense. But in
Yeah.
AND case, I have to do both,
Yeah.
so it won't matter
Same
if I
thing.
did the
Yeah,
first.
same thing. Because we are following the convention in OR, that's why we are following the same convention in AND.
All
Okay?
right. Okay.
Yeah, that is
Okay.
just affecting, because both of them will have to be eventually solved.
All right. Thank you, ma'am.
Yeah, fine. Yeah, Divya, what were you asking? Okay, Divya, I think you told that you are not able to understand this longer path thing. Am I correct? Okay, Nitin is also asking something. Even if we reach the goal state through B, okay, 1 minute. So what is your question? Even if we reach the goal state through B, will we expand C? Yes, you will expand. Okay, so basically one thing is that in order to reach the goal state, you have to expand both B and C, because they are dependent activities. Okay, so that is basically the complete thing which I want to tell you. For solving B and for solving A, you have to solve B also, C also, because it's an AND arc. Okay, so that is not the case that you will be able to reach the goal state through B or through C. You will reach the goal state after solving B and C both, basically. Till when? Till you reach the goal state, till you are able to reach the goal state. So that is the meaning of an AND arc. Meaning of an AND arc is you have to solve both the nodes, then only you can proceed further. Otherwise, you cannot proceed further. That is why you got stuck up here. Okay, see here, students. In this case, you got stuck up because it was an AND arc on C and D. That is why you could not reach to the goal state E via this shorter path. Fine, because C and D are connected by an AND arc and D is unsolvable. That is why you could not reach this goal state E through the shorter path. That is why you chose a longer path, and you would and we were of the view that a longer path is better, because in the shorter path there is an unsolvable node. So you cannot reach E through the shorter path because it's part of an AND arc which is having an unsolvable node. Similar situation here also. The same thing here also. In order to go ahead and go to the goal state, you have to solve B also and C also, because they are both connected through an AND arc. Okay, Nitin, getting Nitin? Yeah, that is why that example, the constraint of AO star which I was explaining, that constraint is also through this property of AND arc only. Because it's an AND arc, so you have to solve both of them. Correct? So it is just a convention that we expand the lower cost node in the case of an AND arc. That's just a convention. But for OR graph, it makes sense, because if you expand the lower cost path, you can reach the goal state independently in the lower cost path only. Fine. And yeah, so Divya, you got the point what I was saying? Okay, Divya, you understood the first thing, the longer path, why it is better? Okay, fine. So any doubt in this one, longer path is better? Then the second thing is, okay, fine. So the second thing is interacting subgoals. See students, here, let us say this is a graph A, and it is the root node, and from A you are generating C and D, and C and D are connected by an AND arc. Fine. Now let us say, so that means in order to solve A, you have to solve C also and D also, and from D you are having a connection towards E. Fine. Now let us say C and D are also connected. So they are connected by an OR arc, right? From C you have an OR arc to D, fine. Or you can say reverse, from D you have an OR arc to C, because you don't know which is the starting node. So but C and D are connected, that is for sure, right? So they are connected by an OR arc. In this case, can you find a solution? Basically you cannot find the optimal solution in this case. Why? Because C and D you have to solve in order to solve A, but what is the actual cost of C you don't know. Why? Because the actual cost of C would be 5 plus 1, or the actual cost of D would be the cost of D plus 1. I mean, you don't know that thing because both of them are also interacting with each other. So what is the order in which you should calculate the cost? That is because of these subgoals which are interacting with each other, the order in which you should calculate. I mean, you don't know the cost, exact cost of C and D. Why? Because if there is no, or there is no arc between C and D, in that case the cost of A would be the cost of C plus 1 plus the cost of D plus 1, right? But now C and D are also interacting, so from D also you will add the edge cost here, right? And you don't know whether you should add the edge cost for of CD in C, or you should add the edge cost of CD in D. That is also one additional thing which you have to do because of their interaction with each other. So it is a case which you cannot handle in AO star search. So AO star search fails to take into account interacting subgoals, because in this case suboptimal solutions would be obtained, because you don't know what is the optimal path, because they both are also interacting. So how you will calculate the cost of C? The cost of C would be C plus 1 for CA and plus 1 for CD, or the cost of D would be the cost of D plus the cost of AD plus the cost of CD. So because they are interacting, that is all. I mean, it is an ambiguity is there in this case. So how do you calculate the cost? So in that case, you will not be able to reach the best cost path because the costs are not calculated correctly. So you can reach suboptimal solutions. So in this case, it will not be able to find the best cost path. Are you able to get this? Students, are you able to get the second thing also? Second constraint? Okay, fine. So this is basically the problem reduction, or you can say the AO star algorithm. Next is I will just introduce it and then we will do it in the next class. Constraint satisfaction. I'll just give an introduction of that. Constraint satisfaction is the next technique under heuristic search techniques. So constraint satisfaction means that you basically want to reach a goal state, and your goal state is basically a state which satisfies a given set of constraints. Okay. For example, let us say a crypto-arithmetic problem. Uh, do you know, students, what is a crypto-arithmetic problem? Crypto-arithmetic problems. Crypto. Okay. Crypto-arithmetic problems is, suppose I am giving you some send plus more is equal to money. Send plus more is equal to money. Let us say I'm giving you this equation and these are some letters actually. Fine. At the back end, they are having some values. Each letter is having some value, unique value. So that will be a value from 0 to 9. Okay. So each letter is having a value from 0 to 9 and it should satisfy this equation. So if you give a unique value to each letter in this equation, it should be able to satisfy this equation. So we have to find out the unique combination of the values to each of these letters so that this equation is satisfied. And the constraint is each letter will have a unique value. Okay. So this is called as a crypto arithmetic problem. So basically, the constraint is given to you that it should satisfy this equation n plus more equal to money. And the other constraint is each letter will have a unique value. So this is just an example I am giving for solving crypto-arithmetic problems. So constraint satisfaction problems are basically the problems in which you want to satisfy a given set of constraints. If you are able to satisfy, then that state is called as a goal state. Okay. Examples of such problems are crypto-arithmetic problems. I will take these problems later on in details also. And many design tasks in manufacturing, they also, some constraints are there on the goods which are to be manufactured. If the designed product is able to satisfy all the constraints, then you say that it is also an example of a the goal state is basically satisfying all the constraints, so it's also an example of constraint satisfaction problem. Then movement of semi-finished goods in assembly line. So basically some constraints might be there. And then planning an optimal tour covering major spots and with minimal expenses of resources. So these are the constraints. I want minimal expenses of resources and I want an optimal travel tour which is covering all the spots. So all these constraints, if they are satisfied, it is an example of a constraint satisfaction problem. So there is no particular search method. You have a search strategy, which actually the search strategy is only this, that you have to satisfy a list of constraints. And these constraints can be updated also. So you, in each iteration, you will update your list of constraints so that you generate new constraints. And finally, basically, you update your set of constraints and finally you reach the constraints which you have to satisfy for the given problem. So suppose you have n number of constraints to be satisfied. Initially, you begin with one constraint, then you add the second constraint and third constraint. Finally, when you are able to satisfy all the n number of constraints, that state is your goal state. Okay, so this is the meaning of constraint satisfaction problems, and then how it works and the algorithm for constraint satisfaction. Basically, whatever I have explained, that is written in the form of this algorithm only. It's already 12 o'clock, so we will continue in the Monday's class, students. Fine. So we'll continue with this in Monday's class. Divya, can you take the attendance, Divya? Done? Okay, fine, Divya. Please mail the attendance to me. Uh, is it okay, students? Anything you want to ask? Okay, fine. Okay, fine. So we'll continue in next class. Thank you. So thank you all of you. We'll continue in next class.